Okay, here's what I want you to know about polynomials. This is kind of what you need to retain to take assessments. As bad as it sounds, you do need to know how to graph them. Okay, anytime I got x to a higher power than a 2, it just goes all over the place. Okay, there's no rhyme or reason to it. And again, the numbers we pick are 3, 2, 1, 0, -1, -2, -3. And yes, unfortunately, you have to plug them all into the calculator. I'll show you how to do 3, and then I'm just going to give you the rest of them so we don't waste time. So 3 to the 4th minus 4, and then times 3 to the 3rd, plus 3 times 3 squared, minus 5 times 3, and then plus 3. I got -12. Now, if you repeat that process with 2, you get -11. Repeat that process with 1, you get -2. 0, you shouldn't have to plug in. If that'll go, because if it's x is 0, that, and that all turn to 0, and you got the 3 at the end. If you plug -1 in, you get 31. If you plug -2 in, you get 73. And if you plug -3 and you get 234, but I'm not going to graph that because it's too far out. I want to go by like tens. Okay, so 3 -12, 1, 2, 3, and then 10, and then 12, 2 -11, 1 -2, 0, 3. Remember, you're going by tens. -1, 31, 10, 20, 30, 31. And then -3, or no, -2, sorry. 10, 20, 30, 40, 50, 60, 70. Okay. Now you got to decide how to put the arrows. The first term, the whole term's positive. So if that's positive, if that term's positive, then the arrow in this direction goes up. Now, for the other arrow, it depends on your highest exponent. It's even, so they'll go in the same direction. Okay, so I got to make sure that I curve this one so it goes up, and then they got to go in the same direction. Looks like kind of a parabola, but not really. It's a little uneven to be a parabola. Okay, if it was x to the 3rd, then that would have to curve down. Okay, cross out that whole next page. That's a waste of time. You don't need to know that. Okay, simplifying the expressions with exponents. Now, you don't see any adding and subtracting here, so that's going to be where I use the 3 boxes. You don't have any adding or subtracting here. That's going to be where I use the 3 boxes. I don't have any adding or subtracting here, so that's going to be where I use the 3 boxes. Here, likewise. I'm going to have to make the 3 boxes smaller, obviously, because my dumb butt didn't make enough space. Now, here you got adding and subtracting to a power, so when that happens, you're not going to use the boxes. You got to replicate your factor in another parentheses, and then you're going to FOIL. Okay, so now let's go carry out these. So, bases are 4 times x. 1 times 3 is 3, 2 times 3 is 6. None of these are negative, so I'm not going to worry about that. And then 4 to the 3rd is 64, and then x to the 6th. Okay, top bases, you got 14, x, and y, and then the new base is just 35. You just got more x's and y's. So 14 and 35 are both to the 1st. Now, x's, we got 2 of them. We have a -3 and then a 1. So I got to do something with the -3 and the 1. Now, this comes from the top, but that comes from the bottom. So when I move to the bottom, I got a minus. -3 minus 1 is -4. So that x is to the -4th power. Now let's talk about the y. We got 5 and 3. Again, the first y is on top, then it moves to the bottom, so we minus, and that's 2. Okay, do you have any negative powers? Yeah, that one there. So you need to keep everything else in the same place, so, okay? Everything that had a positive exponent keeps the same place, but that x is going to the other side so that his exponent can turn positive. Okay, then we have 14 and 35 times y to the 2nd times x to the 4th. Now these two here, the two big numbers, if they're on opposite sides like that, you can reduce them by 7. So that'd be a 2, that'd be a 5. Will I count you off if you forget to do that? Probably not. I will count you off if you forget to multiply, and you're supposed to, though. So my bases are 4, A, and B, and then, or actually I should go 4 times 3. Makes more sense, and then A and B. Okay, so 4, 1 times negative 3 is negative 3. The 3 is to the first, and then A, I've got 2 of them. I got negative 15. Or no, just negative 15. That's your only A. B's, I've got 2. Negative 2 times negative 3 is 6, and then a 5. So I got to do something with 6 and 5. They're both on top, so we just plus them. That's 11. We add them. Okay, I've got a couple negative exponents here. So the ones with the positives stay on top of the line. But the ones that are negative go to the other side. Okay, so 3 to the first is 3, 4 to the third, 64, and you cannot reduce those. So they'll just stay the same. And then B to the 11th and A to the 15th. Okay, next, just extend the line. So on top, you have a base of 7, and then just bases of X and Y. Okay? So 7's to the first. Now X's, I got 3 of them. I got a 1, a 3, and a 2. So what do I do with 1, 3, and 2? Top, and then top, so that's plus, but then I move to the bottom, so I minus. So 1 plus 3 is 4, 4 minus 2 is 2. So X to the second, positive second. Now Y, I got 3 of those too. I got a negative 1, a 1, and a negative 4. I didn't give you very much workspace, obviously. So negative 1, 1, and negative 4. Okay, so that came from the top, but then we move to the bottom, so now I start minusing, okay? Negative 1 minus negative 4. Now that's actually plus on the 4. So negative 1 minus 1 is negative 2, and then plus positive 4 is 2. So the Y is to the 2. So all these ended up being positive exponents, 1, 2, and 2. So get rid of that. 7 to the first is 7 times X second times Y second. Okay, now here we're not using the boxes because when we have adding and subtracting to a power, we need to use FOIL. So 3x times 3x. 3x times 2. 2 times 3x. And 2 times 2. So that's going to be 9x squared. 6x, 6x, and 4, and that makes 12x. So 9x squared plus 12x plus 4. Okay. All right, now we start solving equations for variables. Well, first off, when you solve an equation, there's how many answers depends on your exponents. So there's be 5 on this one. Okay, so 2 terms. So there'd be the GCF. And then we check to see if we have a difference of perfect squares. Okay, and there might be more difference of perfect squares once we get that. So GCF, well, you don't have a negative, but you got x's on both. Not only do you have x's on both, the third power is your smallest, okay? And then you can divide both of those by 3. Okay, so 3x to the third's getting pulled out. And then I divide by 3x to the third. And that gives me 1x to the second power minus 16. Now, at this point, we know we got a factor of 3x to the third, so I want to make sure I write that down. Okay, that's a prime factor, but I look to see if I can bust this down. So DOPS, you got 4 times 4 and x times x, especially if it's a 1. So it's x plus 4 and x minus 4. Now this one has a plus, so it's prime, so I go put that next over here. This one has a minus. Now, do I have the second power? No, I don't, so that's also prime. So the factoring's done. So 3x to the third could equal 0. X plus 4 could equal 0. X minus 4 could equal 0. So I divide by 3, and x to the third equals 0. That means we got 3 of these that could be 0. And I get negative 4 and positive 4. So there we have it. Okay, next up, 3 answers. This time there are 3 terms, so we got to use R, GCF, and T. Okay, GCF, well, you don't have a negative in front, but you do have X. So you got to factor out an X. Okay, so it's going to be 1x second minus 7x plus 10. Okay, so that factor of x needs to be brought over here because it's prime. It's going to be part of me solving it. ABC, that's positive 10, sum of 7, and that's 2 times 5. Now the A clearly equals 1, so I just need 2. So x and 2, 5. So you got minus 7, so you got minus 5 for sure, and a sum mean they're both minus. Now they're both minuses, but they don't have second powers, so they can't be dopses, so they are both prime. So x minus 2 times x minus 5. Okay, so x equals 0. X minus 2 could equal 0. X minus 5 could equal 0. So 0 plus 2, I get 2. Plus 5, I get 5. So 0, 2, and 5. Okay, next problem. There's 5 answers. So it'd be GCFT on this one. GCF, yep, I don't think, yeah, you got X at least, but that's about it. Okay, so X, so 3x to the 4th minus 22x squared minus 45. Okay, so this X, circle that, and you need to put that over here. Okay, ABC, 3 times 45. It's 135 negative, looking for a difference of 22. Now, you can find that because 135 divided by 5 is 27. Okay, so what's your A equal? The A equals 3. So I'm going to need 4 parentheses here. So I lead off with 3, but I've got x to the 4th. So to handle that, we go x second, and then we put the 5 and the 27. So we got minus 22, so you for sure minus 27, and then plus 5. That doesn't reduce at all. The other one divides by 3, so it's x second minus 9, 1x second. This is a plus, so that's a prime factor. Go put it over there. You just put it over here. It's there when I need it. But that's not prime, because not only do you have a minus, you got a second power, and these are both perfect squares. Okay, so that goes down into x and 3, 3. Okay, and that's prime, so x plus 3. And the other one's prime too, because it wouldn't be a difference of perfect squares. Okay, so my x could equal 0. There's first answer. 3x squared plus 5 could equal 0. So I minus 5, I get negative 5. Divide by 3. Look, just keep that as a fraction, I would. And then find the square root. Now, square root, you need to make an I outside. And don't worry about trying to simplify a fraction. Just leave it as a prime square root. Okay? So I've got I square root 5 over 3, and then I square root 5 over 3 negative. Okay. X plus 3 equals 0. You just divide and you get negative 3. And x minus 3 could equal 0. And I get 3. Okay. All right, next problem. There's 3 answers. There's 4 terms, so set up your grouping. Okay. This is factorable, and if it needs to be grouping unless I write the word prime. Okay. So 25x third minus 100x squared, and then negative 1x plus 4. So we can divide by 25 here, and also x to the second. And here you got to divide by something, okay? Because you have a negative in front, you're going to divide by 1. So I pull out 25x squared, and I pull out negative 1. So that's going to be x minus 4 and x minus 4. Okay, so if you look here, we got x minus 4 in each one of these. So I pull out x minus 4. And then I'm left with the 25x to the second minus 1. Now they're both minus, but that one doesn't have a second power, so it goes up here. It's prime. Now this one right here has a minus, and you got a second power, so let's look closer at it. 1 times 1, and that'd be 5x times 5x. So you bet that's the difference of perfect squares. So 5x, 5x, 1 and 1. And then that's prime, and that's prime. So 5x plus 1 times 5x minus 1 equals 0. So x minus 4 equals 0. 5x plus 1 equals 0. 5x minus 1 equals 0. Plus 4, I get 4 for my first answer. Minus 1, I get negative 1 for my second. So negative 1/5. Plus 1, I get 1. And then divide by 5, and you get positive 1/5. Cross, we're not doing that. Next one, and we'll go to this one. Solve the equation. Now, what you need to do is put equals 0, and I will do that for you on a test, and I'll also write the word prime, meaning you can't try to group them. It's not going to work, okay? There's 3 answers. You need to find the first one through trial by error. So let's start plugging in 1. And you're going to use trial and error, and then you're going to use the synthetic division, okay, with 4 terms. If 4 terms are prime, you need to use trial and error to get your first answer, and then the L, the synthetic division L, to get your second. So let's plug 1 in. No. Let's try negative 1. Negative 1 to the third minus 5 times negative 1 second minus 22 times negative 1 plus 56. Okay, let's try 2. Bingo. So you got 2, so now you can synthetically divide by 2. And this is the only way to do this if that's prime, okay? There's no other way. 1 times 2 is 2, so negative 3. Negative 3 times 2 is negative 6. And then negative 56. So that's 1x squared minus 3x minus 28 equals 0. So I don't have a GCF. Now I go to my factoring. So I do my T28 negative difference of 3, and I find that pretty easily because it's 4 times 7. And A is equal to 1, so I just need 2 parentheses. It's x second, so x, 4 and 7. So I've got minus 3, so you got minus 7 for sure, and then plus 4. So you get negative 4 and positive 7. Okay, story problems. For 1995 to 2005, the revenue for producing a product can be modeled by the way, get rid of this. A lot of people see that. Don't even use that, okay? Don't use the time span for anything. It's worthless. Revenue is 1/4 t squared plus 21 over 4t plus 400. T represents the year since 1995. R represents the revenue. Find the revenue earned in 2005. So I got 1/4 t squared R equals plus 21 over 4t plus 400. Okay, let's tell me what those equal. R is the revenue. And T's the years, but years since 1995. Now, pretty much the only number they give me is the 2005. Okay, so 2005 is a year, so it goes in for T, but you got to minus 1995 before you plug the number in. So you're just going to plug 10 in for T. And then I'll have R. And there's only one answer that R can possibly be. So 1/4 times 10 to the second plus 21 over 4 times 10 plus 400. And if you don't want to write everything down, that's fine, okay? But I'm just showing you how it works. Um, 477 and a half, so just round that up to 478. Okay. Okay, now it's a little more complicated in the next problem. Profit for a shoe, it's supposed to say shoe. Shoe manufacturer can be modeled by the equation P equals negative 21x cubed plus 46x. X is a number of shoes produced in millions, and P is a profit in millions. Company produced 1 million shoes and makes $25 million. What lesser number of shoes would yield the same profit? So just like the last one, you need to write your equation down. Let's talk about what the P and the X mean. P's profit, and that's in millions. And the X is the number of shoes, and that's in millions. But they kind of give me two values here, okay? So you got 1 million, and that's shoes. You also got 25 million, and that gives me 25 million. And that's your profit. So we're going to put those in the same equation at the same time, but since they're both in millions, you can eliminate the extra zeros, which makes that nice. So you're going to put 25 in for P, and then 1 in for the X's, because we want to make sure that that actually is legit. What if it's not? Well, probably is, okay? If it's not, you just say problem not right. Yeah, it is, okay? So that's why I want the 25 to stay the way it is. I still want to make a $25 million profit. I just want to find what different X's, what different numbers of shoes we can use. So there's 3 answers, and you already have one of them because you just had one of them in. 1. So move him over, and then we do the synthetic division by 1. So I've got negative 21 for the X to the third. I don't have X to the second, so put a 0. And then X is 46, and then negative 25. So drop him. Okay, so now the new equation, after I divide by the solution, is negative 21x third minus 21x squared plus 25 equals 0. Okay, so GCF and T. Okay, GCF, negative in front, so you at least have negative, and all you can do is the 1 with it, so negative 1. So really all that happens is the signs change to positive 21x squared. By the way, this is x squared, x, yeah, x squared, x, and nothing. I'm an idiot. X squared plus 21x, and then minus 25. Now, when I take the product of A and C is too big, it's too much of a waste of time. It's not worth the time, so I'm going to go to my song, okay? So 21 plus or minus the square root, b squared minus over 2 times 21 is 42. So 21, then 4, a is 21, c is negative 25. Remember, it's negative 25. Negative 21 plus or minus divided by 42. Now I plug that into the calculator. Square root 21 second minus a 4, 21, negative 25. Okay, 50.4. Now I proceed. Negative 21 plus 50.4 equals, divide by 42. I got 0.7. And negative 21 minus 50.4 divided by 42 is negative 1.7. Okay, so these are going to be my two solutions. That one's not viable, and that's million. Okay, so by the way, everybody takes this during the day of the final. I'm just showing you what it kind of looks like. It's not really fun, but luckily you only got to pass it one time. You don't have to keep repeating it. That's kind of the one I put on the final, just because it's not very fun.